Well, welcome everybody. Good morning, good afternoon, good evening. You are joining the session, So Many Words, So Little Time, an introduction to NLP for analysis and insight. And in particular, we hope this is a gentle introduction to NLP. The work we have done and that we will present to you today is really meant for those in the beginning and intermediate stages of thinking about language data and its usefulness to you as a researcher. And as the subtext on the title slide, you will note that we put one of the use cases that we will talk about that you as an educational researcher are beginning to collect or have been collecting and are beginning to think about the language data in your environment and asking questions such as what comes next, what approaches, models, and outcomes can you trust? My name is Pete Smith. I'm at the University of Texas at Arlington, and I am joined today by two other presenters who will each provide material and insight today. Elizabeth Powers and Henry Anderson will each be picking up part of this presentation. I will offer the introduction, and then they will move us into a much deeper look at some of our NLP challenges. We will talk briefly about unstructured data, language data, data which differs from that you might find, say, in a spreadsheet format. We will think about theory and research focuses and how NLP or natural language processing may allow you to work with your language data in that research setting. We're going to talk about one tool in particular today, Luke, that we have found to be a very good first step into the NLP research world. And then as we finish today, Henry is going to talk in particular about some of the more code-based or infrastructure-based approaches to natural language processing, especially for our more intermediate and perhaps even advanced NLP users. They will find, I think, special value in his portion of our presentation today. As any academic, I'm going to start with some definitions. We wanted to share with you the learning analytics frame. When we talk about being educational researchers and collecting data, what you see on the screen is the SOLAR definition of learning analytics, that as all of you, either current or future educational researchers, collect and analyze data about learners in their contexts, this is a frame we will use to think about NLP in particular. And as you will see as we move through our presentation, certainly the natural language processing concepts and tools that we will talk about are not limited to the educational domain. And in fact, you will find that they will have application in a wide variety of business, nonprofit, governmental, and other settings as well. All of us as educational researchers, as learning analytics researchers, are working toward larger goals of supporting student development or skills such as collaboration, critical thinking, communication. And we believe that the language data, the unstructured data present in the environment can be a research focus and can bring insight to us as researchers working and thinking about these particular topics. We are going to focus on a particular set of outcomes here today, those words that might be collected in a variety of settings, and we're going to show you some graphics here in a moment to give you some very concrete ideas as to where you might have language data in your setting. And we are really hoping that as researchers, and really stressing that as researchers, you will bring research questions and theoretical frameworks for the work you are doing. I hope many of you had the opportunity to watch Professor Danielle McNamara's keynote yesterday, where she really laid out the landscape of learning sciences and learning sciences research. And know that in no way are we pointing to any particular area of the learning sciences field. NLP has had its role in studying a large number of student performance areas. If you're doing research in content, if you're doing research in any of the areas that we would say fall into learning analytics or the learning sciences, we feel that NLP and the language data that you have can be reliable and valid measures that drive forward your work within your theoretical framework. We in particular work with a theoretical framework and have worked in several different areas. So for example, if you are a researcher who is considering persistence and why students stay in their particular environments or why they depart their particular environments, you may have a theoretical framework such as that of Vince Tinto. And so just as an example, I'm giving a graphic here noting his theoretical framework. And you will notice that as data could be collected relative to student background, skills and abilities, prior education, to their goals or to their intentions, there are a variety of places in this model where standard structured data, oftentimes numerical data, may provide you only limited information, whereas a student reflection or a student interview or a student who has provided responses to a survey in language data form may be offering you key data for analysis and for insight. We have been working with several different frameworks. We thought we would put another sample up here from Baxter Magolda as we think about how students develop identity and write and think and reflect into one's own identity. You will notice, and once again, this is just a graphic example of one theoretical framework that we as researchers are using. You will have others where you will ground your work. As you think about student beliefs, and in our research, student belief systems or student values, student identity, we find that the words students give us really help drive our analyses forward in ways that structured data might not. A third theoretical framework that we as researchers have used is that of the big two, agency and communion, learners who might be individualistically oriented versus learners who might be more communitarian and group oriented in their upbringing, be that cultural or other organizational sorts of settings. Just quick examples of theoretical frameworks where natural language processing may give you a way to analyze the words or word data that students or learners are offering you. NLP is a computational approach to language. And as you are going to see here in this presentation, all three of us as speakers bring backgrounds in language and backgrounds in linguistics, as well as backgrounds in infrastructure technology and some of the algorithms or tools that make up natural language processing. And I don't think we would be letting out a secret if we note that there is something of a tension there. Particularly, I think you will find this in Mr. Anderson's portion of our talk. NLP and NLP tools, use of these algorithms are all around us. Every time you type on your phone and it autocorrects, every time you type a search into Google and have some predictive typing. These are basic, fairly rudimentary examples of NLP algorithms that have existed for some time. But increasingly, and you may have seen this in several of the packages that Dr. McNamara talked about in her keynote yesterday, we're asking these algorithms, relying on these algorithms to mimic higher order tasks, classifying student responses, helping us to summarize large amounts of text. And even, for example, in my case, where I look at multilingual environments, the notion of machine translation, many people would put in the category of natural language processing. The underlying assumption here is that when you collect words from learners, that the language they use and express as their thoughts is a way of constructing their world. It's a way of interacting with their world. And it's potentially an insight into their cognition and into their thinking, into their learning, into their associations, and into their mental constructs. And in particular, I'm very fond of the second quote, which actually comes from Jamie Pennebaker, a longtime NLP researcher whose work we'll mention several times in this talk. The idea that words leak our cognitive, social, and affective states and practices. So one might directly inquire of a learner about their learning, about the social context in which their learning occurs, about their affective state, or one might use the language that they produce to infer those particular insights without that direct questioning. So the assumption here, words leak our cognitive, social, affective states and practices and offer insight into our cognition that we might not receive in many other ways. The last point before I stop talking and begin to hand this over to Elizabeth is that we are drowning in data. This is canard. You have heard this and seen this in many different settings. This is true not only of life around you, but certainly as well of your educational environment. I'm always amazed by these every minute of the day graphics, knowing that in any moment, 1 million viewers are watching streamed video on Twitch, although I'm less happy that every minute on the planet, nearly 200 million emails are sent, of which I think the majority seem to be coming into my in basket. We as educational researchers are also in very data-rich places. Our institutions collect data about our learners. And so in an SIS or student information system, we'll have a wide variety of bio-demo information, academic progress information. We, in our learning environments, be those formal classrooms or a wide variety of other coaching, tutoring, mentoring, learning, developing environments, we have the opportunity to collect data about our learners. And in particular, where might you be finding word-centered data? As your students write, whether they're writing admissions essays or reflections during a learning process, the words they utter in, say, an interview or focus group, any sort of text assignment or survey represents, once again, based on the assumptions we talked about earlier, a valuable insight into their cognition, into their affective states, and allow us to better understand them as learners moving through a particular process of learning or development. How do you do that? What tools might you point at that language that you are collecting from your students? I'm going to turn this over to Elizabeth Powers, who is going to pick us up and take the story from there.
So for those of you who are part of qualitative research and have done that before, or even if you're trained as a quantitative research like I was, you probably still know that qualitative research, getting a single piece of qualitative data that you can really trust, can take 3 to 5 years. It takes a lot of human resources and it takes a lot of money. So probably the first use case is, do you have limited resources? Do you have too many words to do quickly with just a few resources? I think for me, probably the most important piece is what is missing out of our model? What question can we not answer with quantitative data? So for instance, if you have a computer model, for us, it's often something related to student success. And I need to know, or the research is suggesting that student sense of belonging, or whether or not they matter, affects whether or not it has an effect on their persistence and their graduation rate. We could use a scale to measure those two, but we're not going to get the same kind of broad coverage in response to a scale. We have all of this textual data, and that data can provide us some information about whether or not students feel like they belong. That's a newer piece of research, but it's coming out of the reflective literature. One of the things that we have used it for is in a particular program, Luke, is when the when we were all in the pandemic mode and trying to figure out how this was affecting students. And so Student Success did a survey, and part of that survey was unstructured data response. We took that, ran it through Luke, and what we expected to find was students were worried about health, they were worried about attending class face-to-face, they were worried about all things related to COVID. Well, what we found out through a couple of easy, and it was confirmed by some of the work Henry did, was that students were concerned about student concerns. They were worried about balancing their time. They were worried about how to pass were they going to have enough study time? What were their grades going to look like? All of those kinds of things that we expect for students to be concerned about anyway. So when we look at this, and you just go down through this real quickly, I'm not going to detail them all. It really is ease of use is probably, as you get down towards the large model like Bert, that's going to require more investment in time. Luke is a pretty broad, that's the one I'm going to outline now. Taco and Tails will also give you some pretty helpful things, such as that those are not as common, but they also have some measures that might be helpful. The R and Python libraries, from what Henry tells me, are getting much easier to use in terms of doing some language analysis, but he'll touch on that. Next slide. So what you saw in that Luke slide is that there are, go ahead, next slide, Pete.
Has it not loaded for you?
No, go ahead and go on to the next one. So when we think about Luke, it looks daunting. There's about 100 different variables in it. And what you saw briefly on the other slide, and you can look at it in more detail later, is that there's about 100 different dimensions. And that seems kind of daunting. But it's also one of the strengths, because what Pennebaker says, and he's one of the ones that was a primary developer, is that one of the best things about Luke is that it's actually an advantage to be a content person, because you're able to kind of sort through all these variables and say, what matters in my context? What's going to be important for my theory? And so you know what you need to know, and you don't have to look at all 100 of these. When we think about, can we trust these, there are about 20,000 different articles that reference Luke, because it's about 20 years old. A new version came out in 2022. Next slide. So 22 has an expanded dictionary. It has also gone back through and actually added some things to the dictionary. It's a word count program. So things like, it has a little, as an underlying basis for the dictionaries, it has a little bit more casual, has more social media text in there to make sure that it actually captures. It has some emojis, so it will capture part of that if that's what your students are using. So you could look at the major categories, which we think of as kind of like an indices, or you can look at some of the subcategories if there's something in particular that you're looking for your theory. So when you first get it, it's a spreadsheet. It gives you some measures, and it can be overwhelming, but it's like any other analysis. You get used to it and you say, what's my research question? And you move forward from there. Next slide. So in the new toolbox, there's also a couple other things that you might find helpful. So Pete mentioned agency and communion, the big two. And that is, I'll show you an example of that article later, but that's probably one of our exemplars for how a dictionary would be developed. But it did take them several years. So what they did in the new Luke suite is they made it a little bit easier, a little shorter time frame to customize a dictionary if you have, for instance, already know one of the dimensions that you really need. You can also just kind of get a glimpse of what your text looks like in a word cloud. There's some minimal topic modeling if that's of importance to you. Most of us aren't going to do language styling. However, it will also do some basic arc of narrative assessment, which may prove to be a little bit useful when we think about students, because there's some really early research that is suggesting that students who come into college and write in a more narrative form struggle a little bit more than students who come in being really strong in academic writing. So it gives an opportunity to think about, is this an indication that they're going to need a little bit more intervention to move forward? So I put the Luke app on here. There's also a set of websites at the very end that might be helpful. And this is a really good resource. They explain how it was developed, exactly what it would do. There's, as Pete mentioned briefly, it does have application in multiple languages. And one of the reasons that they work is that the underlying dimensions tend to be consistent across languages, so that if, for instance, pronoun use is indicative of something in English, it is also indicative of similar concepts in Spanish, German, and several other languages. But you can see and that's very helpful. So in the big two, as he said, agency talks about achieving goals. Communion is about forming meaningful relationships with others. So you see this important across domains. They, I believe, were using it in relationship to business, but it's also important when we think about students. And it may prove to be an important factor for us in student persistence. Next slide. So this is one of the, so if you're interested, the biggest issue with using any new tool is often that we don't know how to interpret results. And if you haven't used language data before and aren't familiar with them, you want to know how to do that. So I put a couple in the reference. This is one of the best that shows how to use it. And it shows you an example of how it could be used in a way that you may not have thought about it. He also has a book, and I put that also in there. And I think that has a broader use, and it's getting a little older, but it's still an excellent resource to use in the beginning to think about how you might analyze and use your results. All we're doing today is giving you a really quick overview, but at LAC 23 in March, we're going to actually talk about the applications, and Henry will show you some, and we'll give you that range and how you might use them, how it might apply in your case, in an actual use case kind of working day to day. So that's an all day. So I'm going to turn it over to Henry, and he will talk to you about some tools and other things that are probably of more interest to several of you.
All right, thank you very much, Elizabeth. So at this point, we are going to transition sort of out of the world of Luke and that sort of older school of more simple, but not necessarily simplistic kinds of analyses and tools, and start looking at some of what's been happening in data mining, machine learning, natural language processing, artificial intelligence over the last couple of years. There's some really interesting and really exciting stuff happening there that tries to solve some very different kinds of problems from Luke. But the kinds of problems that they solve and the way they go about them have a lot of potential and promise for both researchers and practitioners alike. Next slide, please. So we're mostly going to be looking at a particular tool called Bert, which we'll go into a little bit more in the next couple of slides. But Bert is definitely a kind of model that is much more at home in what we would think of as artificial intelligence. I know that everybody probably thinks of something a little bit different when we think of the words artificial intelligence, but For most of us, Bert is going to be closer to that. It's a very complex model. It has pretty high hardware requirements, but we're going to see that we get a lot of interesting benefits from that. Next slide, please. The biggest benefit that we are going to be focusing on is the ability to capture much greater complexity from our linguistic data. Luke is great. We love Luke. We use Luke all the time. We swear by Luke. But as Elizabeth did mention, what Luke is ultimately doing is counting words. And anyone who's taken a first semester linguistics course or has studied or thought about language will be able to tell you that counting words is going to be good for some kinds of things, but there is so much more going on in language. There's syntax, there's morphology, there's intonation, there's phonetics and phonology, and then there's the absurdly complex world of sociolinguistics and psycholinguistics. And so if we're going to stick with a tool like Luke, which is counting words, we're cutting ourselves off from a lot of the really interesting richness of the linguistic signal. And a tool like Bert exists in large part to try and capture some of that signal. Next slide, please. And so one thing that's, I want to make sure not to trample over this. We're going to be doing some comparisons over the next couple of slides, putting this big Bert model up against Luke. And Luke is not always going to come out on top. There may be a tendency among many people across many industries to look at these results and think that Luke's not so great, why would we use it? We're going to make some cases for why Luke still absolutely has a place in almost every researcher and practitioner's toolkit. But it's a tool we love. It's a tool that still has a lot of advantages over a tool like Luke. Sorry, over a tool like Bert. Apologies, it's the end of the day for me here. Luke has been a very well-validated tool. There's been a lot of work and a lot of very careful thought that's gone into the creation of the word lists and the dictionaries and the general approach that Luke takes. It's very easy to interpret the results of what Luke spits out at you. As Elizabeth mentioned, even though there are 100+ different measures that it will report for a piece of text, many of them have things like names like positive sentiment, negative sentiment, affect, things that, while they may take a little bit of work, we can still directly interpret them. That's a point in Luke's favor and against Bert, as we'll see in a little bit. But a lot of the simplicity of Luke's approach, while it gives us some of those nice benefits, like it's fast to run, it's easy to interpret, that simplicity is a limitation. It does mean that there are certain kinds of patterns, like those that are dealing with syntax or pragmatics or more complex abstract elements of language. Some of those patterns simply cannot be captured by Luke. But in fairness, if I had to pick only one thing I could use to model language, word counting in Luke probably would be the best bang for my buck. But let's talk a bit about Bert. Next slide, please. So the big trade-off that I'm going to want to focus on and have us kind of keep in the front of our minds for the rest of this slide deck is this trade-off between speed and interpretability and accuracy. A model like Luke, very fast, very easy to interpret, surprisingly accurate, but sometimes we end up needing a greater level of pure predictive or labeling accuracy than Luke is going to give us. If Luke is annotating our texts for positive and negative sentiment, it's not possible to be correct 100% of the time. We have to accept some margin of error on those predictions. And sometimes the margin of error that we're going to get from Luke is too big for whatever we need to do. If we want to make that margin of error smaller, if we want to get those predictions to be more accurate, we're either going to need a model that takes longer to run because it's doing more and processing more about the complexity of language, or we need a model that gives up some of the interpretability of Luke because we want it to be able to capture patterns that may be too complex for us to directly understand. And I suspect that there are some red flags and sirens going off in at least a few people's heads right now about building a model that learns patterns we can't understand. But that's not necessarily a problem. At least not if we think about the models and use them sort of with that in mind. One of the big divides between a tool like Luke and a tool like Bert at a basic, almost philosophical level is that Luke is designed to be, in many ways, a tool for doing science, basic scientific research, and finding and crafting and creating explanations for phenomena that we observe. And one of the critical points of any scientific endeavor is that an explanation should always be simpler than the thing it's trying to describe. Partly because, well, we would like to be able to understand it in simple terms, but also because if we have an explanation that's more complicated than the phenomenon, well, what have we really accomplished? Bert is not a tool that's designed for doing science in that same way. We don't really care when we're using a tool like Bert how complex the things it learns are, because we're not using Bert to open up the internals of the model and see what the relationships are between variables. We're relying on Bert to have a very, very high predictive accuracy. And we can do some interesting things with that are still going to be pursuing the goals of basic science or student support or customer retention or whatever else we may be doing. But we have to think about it a little bit differently. There's something else I had on the tip of my tongue, but I immediately forgot, so it's either not important or I'll remember it in 5 minutes and abruptly cut myself off. Next slide, please. So that's probably about enough hemming and hawing about the philosophical background of this, but sort of recap the last couple of minutes. Luke is a great tool. Luke serves a very particular set of purposes, and it does them very, very well. There are some things Luke is not very good for on account of the simplicity of its approach to modeling language. We're going to demonstrate that in, I believe, starting in the next slide or two here. And we're going to do this in the way that AI, ML, and NLP people tend to do this. We're going to grab a data set. In this case, this is a publicly available data set on the Hugging Face the Hugging Face Dataset Hub, where someone has taken a bunch of discussions on Wikipedia pages and annotated these posts for whether or not they contain toxic language. We're going to use Luke to do feature extraction. So take each one of those posts, get the 100-some features that Luke provides us, feed that through a simple logistic regression to just see, can we accurately predict toxic speech based on the Luke features? Then we're going to do that exact same task, but instead of using Luke to do the feature extraction followed by a logistic regression, we're going to do Bert. We're just going to let Bert handle all of that and not really worry too terribly much about what it learns, because we're interested in how accurate it's going to be. And I did just remember the thing that I was about to say at the end of the last slide. I have been saying Bert, and I will continue to say Bert, but it's important to know that Bert is actually just one of a large family of similar kinds of models. These have exploded in the last 4 or 5 years, and they will broadly go under the name of transformers, which is related to the underlying neural architecture that they're built off of. Bert was the first one that was published. It's one that many people still reach for, and we're going to be focusing on Bert specifically for the next couple of slides, but anytime I say Bert, just think Bert and other transformer-style models, but this is a big mouthful, so I'm just going to say Bert. So we're also going to do the cooking show thing here, where rather than going through all of the code and all the analysis live, I'm just going to jump straight to the results. When we did the Luke-based approach of take the data set of Wikipedia posts, use Luke to do feature extraction, feed that through a simple logistic regression, Luke was able to correctly identify the presence of toxic language about 80% of the time. Not too bad. Whole thing took about 15 minutes to run on my laptop. And because we've specifically chosen Luke plus logistic regression to be very human interpretable, we can pull out the coefficients of the model and take a look at the top couple of, in this case, the top 5 features from Luke by the absolute value of their coefficient. So we see that affect and the use of swear words, and interestingly, both the presence of positive and negative tone are highly predictive of whether or not this post contains toxicity. And these might be some interesting results if we're trying to learn something about what tends to trigger toxic language or what do people tend to talk about when they're already being toxic. These are some interesting insights. Next slide, please. When we do the same thing with Bert, our accuracy jumps up from 81 to a little under 87%. That's a pretty big jump. I can think of plenty of situations in my day-to-day work at University of Texas Arlington. I can think of many situations in industry and research where that difference of 5 or 6% accuracy would be make or break, where that would be huge. So that's a pretty nice jump in accuracy. The Bert model is right about 87% of the time. But the trade-off, because Bert is a gigantic neural network model, I had to run it on a dedicated dual GPU server, and it took a couple of hours. I actually set it up to run overnight and just came and checked on it again in the morning. And because Bert is a gigantic, complex neural network that's learning these extremely high-order nonlinear interaction terms between features we may not understand much anyways, I have no idea what Bert found important in making these predictions. And this one slide right here really does kind of sum up two of the different extremes of natural language processing and of, just generally speaking, using language data in analysis. On the one end, we have a tool like Loop, which, 81%, that's nothing to sneeze at. It's pretty quick and easy to use. It may often be good enough, and it can tell us about the relationships between variables. On the other hand, we can give up the speed of Loop, we can give up the transparency, and in return, we can get a lot of accuracy back. But there's also a dirty little secret on these two slides, because if I'd really wanted to, I probably could have done some model tweaking or parameter tuning or variable selection for Loop to get that accuracy up closer to Bert. And same thing for Bert. I could have probably done some extra parameter tuning and model tweaking and general monkeying around in its guts to make that accuracy go even higher. But this was basically just running the simplest possible version of this code. And interestingly, the complexity of the code I had to write to do both of these analyses, pretty much the same. Each one was about 50 or 60 lines of Python code. Pretty easy to write, pretty easy to read. So really, the sort of the technical limitations of accessing a tool like Bert are mostly going to be in the hardware. And we'll come back to that point a little bit later. So I'm not going to spend too terribly long on this slide, trying to be a little mindful of time and wanting to leave a little bit of space for questions. But remember, second verse, same as the first. This is a quick rapid fire set of results from a different data set. This one is a collection of tweets that have all been annotated for several various categories, showing the performance of Luke plus logistic regression, which is the blue bar on top of each pair, versus Bert, the orange bar on the bottom of each pair. And with the interesting exception of identifying hateful speech, Bert consistently beats out Luke by about 10 to 15% absolute accuracy. 5% accuracy is big, 10 to 15%, that is pretty huge, especially on some of these tasks that are very complicated. So, Bert's great, Bert's accurate. Code for Bert's not that hard to use. Access to GPUs and long compute runtime, not as big of a problem as it used to be with the rise of things like AWS and Microsoft Azure and Google Compute, where you can just rent GPUs by the hour. But let's cycle this back around to kind of where this presentation started and think a bit about Bert in more of a traditional research context. Because this is a place that we've seen people get tripped up a little bit when we're introducing Bert to them in our work at UTA. They present this to them and they see, oh, it's a big black box model. What can I do with that? Well, the answer ends up being pretty much anything you would do with Luke. Most people, when they use Luke, aren't tearing apart the internals to figure out how exactly it's getting to these final predictions of what's the affect or the sentiment score of this particular piece of text. They're trusting that the tool has been well built and validated and that it performs well and accurately. Bert is basically the same thing. The only difference is you're going to be the one doing a bit of the work to get it to that point of having accurate, high-quality predictions for sentiment, affect, tone, whatever else you're annotating for. We don't really have the time to go into too many details about what that whole process looks like, but the extremely short version, you get some texts, you label them by hand, you feed them into Bert, you kind of let Bert handle the rest, figuring out how to map from your text to your labels. Once it's done that, you can pretty much use it like you would Luke or any other text annotation tool. One particularly interesting use case that we have found, not just with Bert, but with more sophisticated machine learning, AI, statistical models in general on the UTA campus is this increasing interest in data triage. So again, being mindful of time, I'll keep this fairly brief, but essentially going back to the question of where can you use Bert that you can't use Luke, or vice versa, what's one good for versus the other? If you have a really, really high quality black box predictions where you can't understand why this prediction is made for this particular observation, if you trust that the prediction is generally accurate, you may not need to worry too much about why it was made. You may be able to say, oh, here's maybe an application essay from a student who wants to come to UTA as a freshman. Some model that we built has said, this student looks like they may be at risk for dropping out or not retaining. We're not going to try and interpret why, but we're going to flag them for an advisor just to check in. It's possible the model is wrong. The advisor will talk to the student and say, nah, you're fine, get out of here. Or it may be that the advisor says, ooh, I would have missed that student. I can talk to them and figure out what they need to do. Essentially, this is just this whole idea of data triage, or triage generally with models like this, is just use them to identify where a human needs to actually spend their time. Don't try too terribly hard to identify what the human needs to do or any of the whys and hows, but just say, hey, someone go check in over there. There's something there that needs to be looked into. Next slide, please. So as we sort of get to the end of this talk, we do have to sort of address the elephant in the room, which is a bunch of the ethical considerations and concerns around a model like Bert. I've kind of been dancing around the black box nature of it and hand-waving some of the problems that come with that, but I can only put that off for so long. With a tool like Loop, or very simple word count methods, or anything that's interpretable, we can directly audit the model itself to figure out what has it learned. If it's learned this particular set of words or patterns of language correspond to some outcome, do we as humans maybe know that, oh, those are linguistic features that are traditionally associated with maybe our first generation Hispanic students, or some other group that maybe we can draw the conclusion, maybe our models learned something kind of problematic here. We can't really do that with a model like Bert. And for some contexts, that may actually be a deal breaker. If you have certain requirements around regulatory compliance or accountability and transparency. There's been a lot of interesting discussion sort of broadly in the AI machine learning world about human-in-the-loop design processes or human-in-the-loop pipelines, where you kind of rely on a human who's looking at the outputs of these models to act as a bit of a guardrail against some things that could go haywire. And there's been some interesting work done in that space. But speaking from our own experiences at UTA, we have seen that that's not always a perfect solution. When you put a gigantic AI model like Bert in front of someone, especially given how hyped up natural language processing has been over the last few years with models like GPT and Stable Diffusion and DALL-E, there is a much higher need to make sure that any humans in the loop with this model are very carefully and deeply trained in how to correctly interpret it. And that's a non-trivial investment. So all this is to say that Bert and the more complex, highly accurate models, they're black boxes. That has some potential drawbacks and ethical concerns. And we can't do an exhaustive list by any means. You may have different concerns in your particular use case, but these are things that really do need to be addressed, because there has also been some kind of worrying results from some of these models about potential biases that they pick up from the data or from the learning task. So next slide, please. Bringing it back around to a happier note, though, depending how you feel about programming. Let's say that a couple of demos and some of this discussion has got you interested in using models like Bert or these more sophisticated natural language processing tools. And let's say that in your context, you've run through the sort of list of ethics questions that may be a problem, and you've decided this is a good fit for what you want to do. Where do you get started? The first question, honestly, one that we keep coming back around to, is to just stop and ask, do you really need to use a tool like Bert? Most of the time, what we have found is that the differences between Bert and Luke for most of the certainly educational kind of work that we have done tends to not be as big as the examples I showed a couple slides back. rather than a difference of 15 or 20% on something, we may be looking at a difference of 3 or 4%. And depending on what we're trying to do, that may not be worth it. Or maybe the extra compute time and resources of using a model like Bert don't quite come out in its favor. And using the simpler, faster, easier to explain tool like Luke, well, oftentimes that's a strong, compelling option. But if Bert is the tool for you, you're going to have to learn a bit of programming. Python is the language where pretty much everything is being done right now, but increasingly Julia and R are getting really high quality interfaces to a lot of these kinds of models. Probably also C, C++, Java, JavaScript, pretty much any language that most people would care to use. We have been looking for, and we have not really found a good graphical interface tool for interfacing with these cutting edge models. It's kind of one of the downsides of being on the cutting edge. But in addition to the time and skill investment in learning how to use something like Python, Julia, or R, there's going to be some hardware investments in potentially expensive GPUs. But once you've got that out of the way, install the transformers library from Hugging Face, and honestly, you're kind of off to the races from there. Next slide, please. This is going to be the note we end on, that I've kind of swept a lot under the rug here. While we've done a bit of a whirlwind tour through some tools and conceptual foundations of natural language processing and working with text data, especially if you want to get into something like Bert and the more cutting edge research, this is a very deep, very technical field that requires a fair bit of expertise. So while you can learn a little bit of Python, get a GPU, install transformers, and be off to the races, that's kind of like saying that, yeah, you can drive a Formula One car. You just get behind the wheel, strap in, and hit the accelerator. If you want to get to the level of using a tool like Bert or any of the other innovations in NLP to their fullest potential, there's really no shortcut around investing in the time and the expertise to do that. Because these tools come out of machine learning, you're going to need to either develop or acquire some skill in machine learning, whether that's taking courses and practicing and studying on your own, or hiring and working with people who already have that expertise. You're going to want to spend time getting really good at the programming aspect. It's very simple these days to just get a model up and running and do the basics with it, but as soon as you need to start doing anything a little more custom or complex, you're going to need to have a pretty good amount of coding experience under your belt. And you're also going to need to make the additional investment in learning some of the more underlying neural network and machine learning libraries. The three big ones right now, at least in the Python world, are PyTorch, TensorFlow, and those two in the prettier colors are JAX and Flax, which are interesting emerging options. But overall, while that is a little bit of well, not a little bit, that's a pretty big ask and a pretty big investment, it does pay off. But going back to the main point from the previous slide, it's worth asking if that's needed for you. Bert has a lot to offer. So does Luke. At the risk of not leaving any more time for questions, I'm going to somewhat awkwardly cut myself off there. We do have, at the very end of this slide deck, which I believe we were planning to make this available somehow, we have links to a couple of websites and resources that we have found helpful both in our own work and in onboarding people into this kind of these kinds of projects. And next slide, please. We also have a handful of references to a few papers and publications that we've made reference to and have also found helpful and good jumping off points for getting into NLP and NLP in educational research. So we very much hope that those will be of use to you. And as Elizabeth alluded to, we also very much hope to see some subset or superset of you all joining us at LAC 2023, where we will be running a workshop focusing on language data in education. So hopefully this has been a preview of what will come in March or April. I probably should know when that's happening. With that, I'm going to stop talking and see if we have any questions.
We have about 5 minutes left, probably practically 3 minutes left. If you do have questions you'd like to address to us, we're delighted to do that. And we thank you for joining us today. We encourage all of you to think about the value of unstructured data, language data that you may have access to, that you may collect in your environment, and the value that it may bring to you as a researcher. These are conversations that we have every day. We look forward to you entering into that community of conversation, and wish you best of luck as you do so in the future. I will stop screen sharing, and we will be able to look at some of the questions in chat. And we're watching both the Whova chat as well as the Zoom chat to hopefully address any details or questions that you might present to us.
Pete, somebody had placed a question about what are some initial good readings to do in NLP, and I answered it in Whova. But I think the two Pennybaker has a book and an article that I mentioned, and then the two handbooks in the first and the second edition of Handbooks of Learning Analytics, and those are available by free download. And each of those has a really good explanation of what it is, how you might use it, what kind of dimensions you can get. So I think those are some good resources to get started. And you can always email one of us for some additional references if you have some specific questions.
We have a very good question in the Zoom chat about human-coded or hand-coded qualitative data versus NLP, and a very large debate, a scholarly debate that has gone on for several years. I would duck that question partly by noting that most of the NLP use cases that we see, and I would put this both in the research context as well as in, say, a business or other outside context, tend to be cases where the amount of text is so large that human coding is simply not in reach, that scale is so large. Going back to Henry's example of toxic language, we all know that major social media companies have been struggling with building models and identifying toxic language in an algorithmic way, in part because there is simply too much for human moderators to judge. As I said, I'm somewhat ducking the question here, but you can see the conceptualization. And you will find in any social media setting, there are both human moderators, folks who are in essence coding posts or other materials as toxic or not, and algorithmic approaches where the machine learning approaches become valuable would be in, say, a social media giant that's looking at 1 billion posts a day or 1 billion posts a day across 140 plus languages, where we simply have too many words, the judgment have to be made too quickly, and other variables such as too many languages or other contexts, where an algorithm, although not perfect, right, maybe only with an accuracy of 70 or 80%, might make a judgment about that post you're about to put up in Facebook, whereas a human might be pointed to that post were somebody to make a filing about it or make a complaint about it or flag it in some way. So some of these debates are playing themselves out in very interesting ways. Some of the biggest producers of the large language models that Henry mentioned are the social media giants, the large companies with digital services. We are at 6 o'clock, so with Grace's help, we are going to end the session and stop our recording and thank all of you for joining us today. And we look forward to continuing these conversations. We put our contact information up. We will share slides as we have the availability to do that. And we wish you a very good and resourceful conference here with empowering learners through AI. Thank you, Henry and Elizabeth, as well.
One last little note. If you had a question that you weren't able to ask us or we weren't able to respond to, please post it in the Whova Q&A section, and we will be popping in periodically to engage with questions there.
And we will go ahead and end the session, which will end the recording. Thank you all for joining us. We appreciate your participation and look forward to hearing from you. Thank you again.